This recording is for Primary Math 6. We're working in the Intensive Practice Book, pages 5 through 11. Before we start this recording, I want to make a couple of comments because we are doing some pretty amazing stuff in this section. The first thing I want to ask you to do is to remember that this book jumps right in with algebra. Don't be alarmed by that. The entire Primary 6 is not that way. We go right to a review stuff, and matter of fact, the B books of this series are complete reviews, nothing new at all to be learned. So it just the order it does this is it jumps right in with the algebra quote-unquote portion of it, and this is largely why I would say this has plenty of pre-algebra involved in it, again with a few additions to make it a pre-algebra course, but just don't be alarmed if you are looking at this thinking, wow, how did we get here? And then the next thing I would say is, when you have your child doing these problems, please work hard to stick with logic over necessarily teaching them steps, memorizing an algorithm. They will get there, they'll understand that, but at this point I'm really wanting them to think very concrete about the math that they're seeing. So with those two pieces of advice, let's go ahead and start with problem number 1. Here's how I would show it in a concrete way. If we have 11 boxes of cookies and each contains T cookies, and the question is how many cookies in terms of T were sold. So first off, when we use the word in terms of, when you see that, if it's in terms of T, let's just say that, then your answer is going to be the answer that you're looking for is going to have blah, 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 and a T in it. T might be plus, minus, times, divide, it doesn't matter, but your answer is going to be equal blah, 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 T. In terms of T means T is the only variable that happens in the answer part. Okay, now here's what I mean by keeping it very concrete. We have 11 boxes of cookies. That's 11. If I have one cookie in each box, then you ask your child how many cookies were sold altogether, you would have 11 boxes, one cookie each, that would be 11 cookies. Okay, we say to our child, what if I had 2 cookies in every box? Your child will say, well, then you have 11 boxes times 2 cookies, or 22 cookies. Now, maybe your child says 2 times 11 because there's 11 twos. Yeah, are there 2 11s? I guess there's really 11 twos. Okay, anyway, leave it like that. So when we try to figure out how many cookies there are, if I know a number, if there are 5 cookies in each box, then I could say there are 11 fives for 55 cookies. So the thing we have to do with this, not that, wrong button. The thing we have to do with this lesson is to help them understand that since it worked the same no matter how we did it, 1, 2, or 5, if we don't know the number, it's okay just to say 11 times T. And a simpler way to write that is just 11T. When we see 11T, what we know is we mean 11 of those, 11 T's. And so how many cookies in terms of T were sold altogether? Answer choice A needs to have units. You would say 11 T cookies were sold. And if you want an equal sign, you can say 11T is equal to the number of cookies sold. Okay, and then part B says this, what if T is 6? How many cookies were sold? Well, 11T, if T is 6, means 11 times 6, which means 66, and of course units are important. 66 cookies were sold altogether. Take it to the concrete, help them understand what would you do, and then they realize that if there are T cookies in each one, what I have, of course, are 11 T's. And when we say 11 T's, we can write it just like this. Okay. Let's look at number 2. Making it concrete by drawing a picture. This says that 5 men shared the cost of renting a boat equally. The rental cost was $C. How much did each man contribute in terms of C? We've done this kind of problem so many times, our students can see that you take C as the entire amount, you divide it into 5 parts, and this is the first guy, and this is the part that the second guy pays, and all the way up, this is the equal parts. Now this is just a sketch, of course, so we're not really worried about making them look exactly equal. But these are the part that each man paid. What is a way that I could talk about that much of it? I would say C divided by 5. And that's how much he pays in terms of C. Again, in terms of C means C will be in your answer. Units. Each of them is going to pay the total cost divided by 5, and that'll be an amount. Now, if that's not enough, ask your child, well, what if a boat cost $5 and you had to divide it among 5 people? What if the boat cost $20? You'd have to divide the boat among 5 people. And look, I forgot the dollar sign on that first answer, right? And so then if you say, well, I don't know how much it cost, I'm just going to go with C. If I don't know how much it is and I call it C, I'm still going to divide it by 5. And a more convenient way of writing C divided by 5 is C over 5. A fraction means division. It always means division. And that's an amount of money that they each contribute. Then it tells us something pretty interesting. Part B says that 2C is equal to $450. This is a great time to introduce to you and to your students the idea of talking about values of things. We know that an equation means things are equal. I like to think about the idea of things being balanced. So if there are 2 C's, that's what 2C means, C and C. And then if it's equal to $450, basically what we're saying is this is half of it and this is the other half. Because notice the 450 and the C's, the 2 C's are balanced. So then if I said, well, take that 450 and divide it by 2, the hundreds would be 200 and the 50 would be 225. And so that would tell me that the C value is 225. That's what they want us to find out. Well, no, that's not the end of it. That's the first step, though, because the question is, how much did each man have to pay to rent one boat? According to what we found here, each man has to pay C divided by 5. I've now found that C is 225. 225 divided by 5 is the answer I'm looking for. How do you do 225 divided by 5? Probably been a while since you've done it. Let's talk about that for a moment. I'll do it over here and I'll do it in orange. Of course you could take 225 and put a dividing sign over it and take 5 into 22 and 5 into 25, and that gives you an answer with no remainder, answer of $45 each, right? So C divided by 5 is $45 for each person. We said in A that C over 5 is the amount that each person had to fund, and then on part B, if 2C is 450, then I can figure out what C over 5 is by doing that two-step problem. Another option, by the way, to take 225 and divide it by 5, if I think of 225 as 225, if I divide by 5 for each of these, 20 tens divided by 5 is 4 tens, 25 divided by 5 is 5, so that's another way I can mentally think about 45. So that tells us that how much did each man have to pay for renting a boat, and that answer is $45. Number 3 is kind of a tricky one. And it's only because of the wording. You have to really pay attention to the wording. This says my sister has $6. I have M times as much money. So M times her money, M times 6 is 6M. And so the question is, in terms of M, how much more money have I than my sister? What it's asking us to find is this amount up here. 6M is more than 6. I keep writing this backwards. 6M is more than 6. The question is, how much more money have I than my sister? This is the more part. And the answer to the more part is a subtraction problem. It is simply 6M minus 6. All of his money, subtract her money, tells you how much more he has. Again, why not make it concrete? Let's say that she has 6 and he has twice as, be too many 6s would be confusing. Let's say he has 3 times as much. That'd be 18. 18 minus 6, how much more money has he than his sister? Would be 18 minus 6 is 12. He has $12 more than his sister. How did I find that? I found that she had 6. I found out how much he had, and I did a subtraction problem. That's why I subtracted 6M minus 6. Okay. Now, then it asks me, now I just made this up to make it concrete, and I think that's a very big skill to learn. Make sure your students know how to do that. That's kind of the point of most of this. Then it says we have a total of $24. What is the value of M? Okay, again, sister has 6, he has 6M. It's a total of $24. Rather than making this a big algebra problem, I would like to keep it really concrete here and say this. 6 plus 6M, there's my 6, there's my M, 6 M's. I'm going to make some blocks of 20 and then 4 ones. Now, this is even, it's balanced. This is the same verbalization as you're going to use in an algebra classroom. We're going to make sure it's very, very solid with a scale. Okay, so if I want them to be balanced, I would have to take off all 6 of those, and to keep it balanced, I'd have to take 6 off of these. So those 4 go. This one has to be broken down into 10. I've already gotten rid of 4 of them, and I have to get rid of 2 more. That means that on this side, I now know I have a total of 18, and I have 6M balancing that, which simply tells me I'm going to take my 18 and divide it into 6 equal groups, and that'll give me 3. The value of M is 3. If each of these is 3, right, then 6M is the same thing as 18. You can talk with your child on whatever level they can handle about a shortcut for that. You could show them the algebra steps. The point is, what I did was say, to keep it balanced, I have to take 6 away on this side and 6 away on that side. And when I do that, I'm left only with the M on the left side, and I have 18 on the right side. And then I have to divide both sides by 6 so that I have 1M is equal to 3. It's an algebra equation done in a concrete way. You can help your child decide if they can see the algebra steps in green, or if they just draw a scales to balance it and understand how to do it from there. Number 4. The cost of 3 bottles of mineral water is W. These are my lovely bottles of mineral water. And the cost over on the other side that balances it out is W, and this is nice and even on my scales. The question is, how much does a dozen bottles of mineral water cost in terms of W? Well, this is 3. If 3 bottles is equal to W dollars, then if I did it again and again and again, That's 12 bottles. Each of them is worth W. So 12 bottles is worth 4 W. W plus W plus W plus W is equal to 4 W. So that's how much 12 bottles is worth. Part A, how many does a dozen similar bottles of mineral water cost in terms of W? And the answer is 4W. If half a dozen cost $4, what's the value of W? Go back to our picture. Let's go back to a half dozen. That would be 6. For part B, I know that 6 bottles is equal to 2W. I also know, according to the problem, that that's equal to $4. So if I took these off and replace it with $4, it would be equal. If $4 is the same thing as $2 times W, then W would have to be $2 to make the information correct. Number 5. Neil gets $4 each day for allowance. So every day he gets 4A. He spends A every day, so what he has is 3A. How much does he save in a week in terms of A? In 7 days, he's going to have $21A, and that's what he saves in a week. Okay, we're not writing equations, we're thinking logically and sequentially. We're teaching our mind to go there and think through it. He has 4A a day. He spends A, saves the rest. Every day he saves 3A, so in 7 days he saves 12A, and these are all dollars, of course, so our units are in dollars. This is part A. Part B asks, if he saves $10.50 in a week, how much is his daily allowance? Two ways you can do this. One is to say, if he has $10.50 in a week, then I could divide that into 7, and this would be each of the days, right? And each day we know he saves $3A, right? So I can very easily say $10.50 divided by 7. When I do that, if I want to do mental math, if you want to write it out and do the algorithm to do division, that is fine. If you'd like to do it with mental math, you can think of it this way. 7 and $3.50 is $10.50. 7 divided by 7 is 1. $3.50 divided by 7 is 50 cents, because notice I have 35 tens, right? 35 dimes divided by 7 is 5 dimes. So $1.50 is each day's worth. And then if $1.50 is 3 of something, then of course I need to divide that down into 3 parts. I have 15 dimes divided by 3 is going to be 5 dimes, 50 cents. And I think it's a great thing to understand, to be able to do it with logic, but don't stop yet, because the last question is, how much is his daily allowance? We know that every day he has 4A, so 4 times 50 cents is $2. And that is how much his daily allowance is. Now this problem, I took 1050 and I divided it among 7, so I knew that each day there is $1.50, but remember each day is 3A, so 3A is $1.50, and that tells me that an A is 50 cents, and I went 4 times A in order to solve the problem. That's many steps. It's a multi-step problem where, again, we're learning to think and organize and keep track of it. Another option we have here is to realize that 7 days savings is $21A, and so if you take the $10.50 and divide it by the 21A, or by the 21, it would tell us how much each of the A's is. If 1050 is 21 of those A's, then if I divide by 1050, I will know how much 1A is. Now, 1050 divided by 21 isn't as easy until you start thinking about 50 cents, right? How many 50 cents are there in $10? 20. And look, there's another one. So when you do that, again, thinking logically, you don't have to do a big division problem. If you take 21 50-cent pieces and divide it into 21, you're going to get 50 cents. And if A is 50 cents, 4A is 4 times 50 cents, or $2. Takes a little more thought to divide 1050 by 21. On the right side of the page in the blue, we did 1050 divided by 7, and then I took that and divided it by 3, which is the same thing as dividing by 21. Interesting how it works, and again, how we're doing it logically and with methods and sequential thinking than necessarily by simply set up an equation and solve. We haven't done equations, we're not solving equations, we simply want to learn how to think right now. Number 6, another interesting problem. An average, by definition, is a sum of numbers divided by the total number. And this is absolutely the kind of problem you see on an SAT, ACT test. It's very important to understand how these work. We're told this, the average of 6 numbers is n. So if you find the sum of the 6 numbers and you divide it by 6, the answer is n. Now, and then you're told that the average of the first 5 numbers, so sum of 5 divided by 5 is equal to 11. I actually know that number. Then it wants to know the value of the 6th number in terms of n. What is this 6th number? Well, here's what we know from this. Again, we're going to keep it really, really concrete. These are 6 numbers. They're not all the same number, so my block is not evenly divided. If I take the first 5 numbers and I add them together and I divide it by 5, the average turns out to be 11. So these are all 11. Pretend like they're really equal. So what that means is the sum of these 5 is equal to 55. That's what an average means, right? If the sum of 5 numbers, very important, if the sum of 5 numbers divided by 5 is 11, then the sum of the 5 numbers is going to equal 55. Well, guess what we know on the top one, right? The sum of the 6 numbers is 66, right? And so the question is, what is the value of the 6th number in terms of n? If the sum of all 6 numbers is n, and the sum of these 5 numbers is 55, then this number right there is n minus 55. Isn't that, I should say, isn't that easy? It would be that answer, except that I did n in the wrong thing. The average is n. So what that tells me is of this whole thing, if I did all 6 of them nice and evenly done, which that's not very even, then each of these is going to be n. I need to go back to this page where I said the sum of 6 is 66. It's not. The sum of 6 is 6n. Okay, by the same reason we have 55, by the same blue picture right here, this sum is 6n. So, just like I said a while ago, if you want to find the sum of all of them, or the value of this last number, it will be 6n minus 55. The entire thing, subtract the 55 part, will tell me that last little bit that I have. That is the value of the sixth number in terms of n. Tricky, but the big thing to know, number one, is the definition of average, and number two, this fact that if the average is n, then the sum of the numbers is 6n. If the average of 5 numbers is 11, then the sum of the 5 numbers is 55. That's a really, really, really helpful application of average that students need to make sure they understand clearly. Number 7. This is talking about two boys, Aman and Bill. And it says that Aman weighs 3 kilograms more than twice what Bill weighs, and Bill weighs X. So here's X kilograms. That's what Bill weighs. Aman weighs 3 more than twice. So this is twice what Bill weighs, and these are each one more. So Aman weighs 2X plus 3, and Bill weighs X, and our units are kilograms. We usually put the parentheses because it's 2x plus 3 kilograms, not 2x plus 3 kilograms. So the parentheses help us remember that everything in there is kilograms. The question is, how much do the two boys weigh in terms of x? If I combine them, I have 3x and 3. Again, I need kilograms. The parentheses just help me to see that the 3x is also done in kilograms. And that one's pretty straightforward. Number 6 was a little more difficult. Just because one is difficult, please don't assume they'll all be hard. Number 8, Mr. Fishy bought a tank for $15 and 10 fish for F$ each. If he gave the cashier two $20 bills, write an expression, or what was his change in terms of F. If he gave the cashier two $20 bills, then he gave them $40. From that $40, he spent $15 on a fish tank, and then he spent 10 F dollars. Okay. And so then how much change he got back, if what was his change in terms of F, this is equal to 40, take away 15, take away 10 F. That is equal to his change. And you can certainly put parentheses around it, put a $sign in front of it, be very appropriate. That's his change. What he had left of $40 is 40, take away the 15, take away 10 of those F's, and that's what he had left over. Number 9, more thinking than actual computation involved. Miss Nina spent P% of her money on a ring. We don't know how much money, just P%. We know that she spent, on a necklace, she spent twice as much. So that's 2P%. Again, if you spent 5% on a ring and you spend twice as much, that's 10%. So P and 2P work just fine. And the question is, what percentage of her money was left after that? Well, remember, you start out with 100% every time. And we've got to subtract P, and we've got to subtract 2P. So when we get rid of that, what is left, that's this part, what we want to understand about what was left is that it is 100 minus 3p percent, that was bad, left. That's how much of her money was left after she made those purchases. Number 10, pretty straightforward. In terms of W, what is the perimeter of a rectangle that measures 12 centimeters by W centimeters? And again, a perimeter, you can do it several different ways. The way that often is most helpful is to think of a perimeter as 2 length plus width. In other words, this is a length plus a width, and if I had that twice, that's the perimeter. We've walked all the way, started here, we walked all the way over here and down here, then we walked back over here and up here. Now, of course, I mean, you're walking on top of the rectangle, not on the outside path. I'm just trying to do the dots so you can see them. So twice length plus width is really the easiest way for perimeter equation. It translates better in later years. You can, of course, say length plus width plus length plus width, same thing, or twice the length plus twice the width, same thing. This version of the equation will help some later on in ways that the other two don't. It'd be good for them to see it's the same thing, but I would suggest that you use this version of perimeter. And so the perimeter of the rectangle is simply, it is 2 times 12 plus W. Now they use W for the width or for the side, and it is W, and that's okay. If you have 2 12 plus W, that's one way to write it. We could also say, well, 2 12s, that's 24, and 2 W's, that's 2 W's. Look what I did. I actually used that one closer, right? This is 2 times 12 plus 2, in other words, W is W, and so 24 plus 2W is the perimeter. Same thing. Okay, good idea to have more than one way to solve a problem. But when you get your answer, please don't forget, you need to have units on it. 24 plus 2W centimeters. Number 11 calls back some information we haven't done since last year, primary 5. 2 adjacent angles lie on the same straight line. What they mean is this. These are the 2 angles. If one of the angles is A, you're trying to find the size of the other angle in terms of A. Okay, this all makes sense if you remember that a straight line is 180 degrees. So if that's 180 and this part is A, the part I'm missing would be 180 minus A. See what happens when I subtract the A part? If I get rid of that, what I have left over is this one that I'm looking for. So that's 180 minus A degrees. Okay. Number 12. What is the area of a square of side S centimeters in terms of S? If this is a square and each side has S centimeters, the area of a square is length times width. In this case, well, or we call it side squared. In this case, the side is S, and so kind of it's so easy it's hard. Maybe it gets confusing because all these same letters keep showing up. It's S squared, but area is always in square centimeters. So if S, let's say you have a square of length 5, the area is 25 square centimeters, they know that, but the reason it's that is because it's 5 squared, 5 times 5 centimeters squared. And you could do this same thing with any number you want to. If it's 2 and 2, if it's 100 and 100, the area is going to be the side squared, and the units will be square centimeters. That's what this problem shows us. This answer shows us that whatever the side is, if you square it and put your units down as square centimeters, that will be the correct answer. Number 13, the volume of a cube of edge E. A volume is length times width times height. And in this problem, since it's a cube, I know that the length and the width and the height are the same. So it says that let E be the edge in centimeters. So when I look at my box, I have E centimeters, wide, tall, long. So it's E to the third. E times E times E is E to the third. And the edge is in centimeters, so it's centimeters to the third. And so that is the solution for number 13. Just kind of helping our students get comfortable with variables, with letters, instead of always having a number in the answer place. Here's a very interesting question. Again, takes some organization of brains to get it done. Notice we're on the last page and of this section, and the problems often do get harder. And so this was one that's going to take a little bit of abstract thinking, but they can do it. What is the height of a cuboid in terms of V, with the volume of V meters cubed and a base area of 24? All right, we're all about organizing this information. Here's a picture. I colored the base, the very bottom of that cuboid, blue. Now, by cuboid, what they mean is it's not, all sides are not equal, okay? And so that bottom base is colored blue. I've labeled length, width, and height. On the right side, we know, of course, that volume is length times width times height. We know that area is length times width. For this particular problem, back on the left side, the volume is given as V cubic meters, and the base area is given as 24 square meters, and we're supposed to find the height of the cuboid in terms of V. Well, using these information, the area is a nickname for length times width, and this is length times width. So from this volume equation, instead of volume equals length times width, I can say that volume is the area of the base, of course, that's the only area I'm talking about, times the height. And then I know that the base area is 24. That is what this is. So the volume is 24H. And by the way, they made the volume equal to V, so V is volume and V is the value of the volume. But the question is to find height in terms of V. In other words, I want to have the height is equal to something, and the V will be in that answer. If you have to find 24 times height to get V, then if you undo that, you have to have V, or volume, divided by 24. Okay, now if they're not sure why, wait, what is that? Sometimes we have to go back and remind them. Okay, sometimes it feels harder when you use numbers that are not as obvious. But if I tell you that 6 is equal to 12H, that didn't work so well, let me pick better numbers. 6 is equal to 2H, then you know that H is 3. How come? Because 2 times 3 is 6, because 6 divided by 2 is 3, right? So if 2 times H is 6, then I want to find H. I do it by undoing the multiplication by dividing. 6 divided by 2 is 3, right? Anytime you have A times B equals C, you know that C divided by B equals A, and also that C divided by A is equal to B. That's something your students definitely know. Now, they're not used to seeing it with variables, but it's absolutely true. So the height is V divided by 24, and by the way, we always have units. The height is in meters. Okay, so we don't know what it is, but it's V divided by 24 meters. Number 15, a machine can fill F cans of food per minute. How many cans will the machine take to fill in 4 seconds? Well, here's a minute, and I want to have 4 seconds. So if I think about it, let's call this 60 seconds. And if I think of 60 seconds divided into groups of 4 seconds each, right? 60, mentally I'm thinking 60 is 40 and 20. That is 10 and 5. There are 15 groups of 4 seconds in a minute. As soon as you run out. There's 15 groups of 4 seconds. Now, if you make F cans in the whole minute, what do you get when you make every 4 seconds? This one, and this one, and this one, and this one are all the same size. So the value of F is divided into 15 even groups, and in a minute, or in 4 seconds, you can do F over 15 cans every 4 seconds. Now again, if that seems too hard to start with, think of something you can do. Let's say that you have your machine and it makes 60 items in 60 seconds. How much does it make in 4 seconds? Right? It makes 4 things in 4 seconds. How did you do that? Well, 60 seconds divided by 60 items is 1 item, right? 1 item per second. Okay, so in 4 seconds you did 4 items. My point here is, and I really didn't write this down as clearly, this is 4 seconds. Point being, by making it concrete, okay? If F confuses him, pick a really convenient number. Maybe use 120 items. Okay, if you make 120 items in 60 seconds, then of course you make 60 items. Sorry, let's do it differently. Yeah, divide both. It's a ratio. It's so easy, it's a little hard to know how exactly to say that, right? 120 items in 6 seconds, or 60 seconds, if I divide it into single increments, right? 120 divided by 60 is 2. That means you make 2 items in 1 second. So 4 times 2 is 8 items in 8 seconds. So it's the same thing over here. If I have F items in 60 seconds, the reason I got 2 is because I did 120 divided by 60 to find out how many items I can make in 1 second. Number 16. How many 1/6 are there in N holes? The way to look at this is a guess and check, or an organized method, right? There are 6 1/6 in one hole. One whole thing, right? One whole thing has 6 1/6. If you have 2 of them, you have 12/6, right? How many times will it take for your child to understand what we're doing? I don't know. If you have another one, you have 3 whole pieces, you're going to have 18 1/6. How am I getting the number each time? 6 1/6, 12 1/6, 18 1/6. I'm taking 6 times the number of holes. Every hole has 6/6 by definition. So there's no real units to put with that. There are 6 N/6 in N holes. Okay? Starts sounding really confusing. But you got this. The last part of this recording are the challenge problems. In the challenge problems, number 1, the amount of ingredients for a basic recipe for 1 apple pie serves 4 people. So we have 1 pie, 4 people, and 1 set of ingredients. 1 the amount of ingredients for one apple pie serves 4 people. So the question is, how many times the amount of ingredients are needed to serve P people? Well, how many times the ingredients? 4 people need 1 set of ingredients. If I have a second pie, we'll count these together. This is 2 pies. It's going to be 8 people and 2 sets of the ingredients. So what does it say? How many are needed to serve P people? And I know if I have 12 people, sorry, my writing's going bad as I try and get through this. It's a long recording, I'm sorry. It's just a lot to say in primary 6. 12 people need to have 3 pies. How do I know that? Because 12 people divided by 4 is 3 pies. At some point we begin to realize if 12 is a number of people, when I divide it by 4, I know how many pies I need. So part A says that I need to know P, which is the number of people, divided by 4, and that's going to tell me the number of pies that I need to make. Now, we don't need to do, for those of you that know this terminology, integer step functions. We're not going there. We're just going to assume that you're going to have a number of people as a multiple of 4. We're not doing any kind of fractions and saying, well, you can't make 3.5 pies. You have to either make 3 pies or 4 pies. We're not going that complicated. Primary 6, keep it in mind. Don't make it hard. Oops. Part B of that one, however, if 3 apples are needed to make 1 pie, how many do you need to make pies for P people? Well, we just said that I'm going to make P over 4 is the number of pies. And so if every apple, or every one of these has 3 apples, right, then what I need to do is take the number of pies and multiply it times 3. So 3 times the number of pies. Now when you multiply, you generally make them both fractions, and multiplication is very simple. 3p over 4 is the number of apples that you have to have in order to make enough pie for P people. Number 2 is totally a words problem. What is the difference? When you see the phrase, what is the difference, you know you're going to subtract. Between, here are the 2 things, between a cube of a number n and the square of the same number. If you have n, the cube of n is n to the 3rd. The square of n is n squared. What's the difference between the cube of n and the square of the same number? N to the 3rd minus n squared. Yes, it really is that easy. Look at number 3. Sunny had M marbles in a jar at first. So here's my jar. In my jar I have M marbles. He added more marbles to the jar, and the total number of marbles became 30. The number of marbles he added is more than the number of marbles he started with. So the pink part is bigger than M. And the question is, how many more marbles did he add to the jar than what he had at first? Again, that word more is kind of tricky. One thing I do when I have a problem like this is set it up as a concrete number so I can help my students, my children, understand what this is. So let's say, for example, I had 5. Well, if I ended up with 30, then I must have added 25. How many more did I add than what I had at first? See, I added 25, but how many more did I add than I had at first? I added 20 more than I had at first. It's confusing wording, but it doesn't say how many marbles did he add. And in math, the words are meaningful. Not if it's not how many marbles did he add, if it's how many more marbles did he add than what he had at first. He added 20 more than what he had at first. Okay, and again, that takes a little bit of thinking. But that's the answer, not 25. They're not saying how many did he add. They're looking for the answer for 20. How many more did he add than what he had at first? So going back to this one, if the whole thing is 30 and this part is m, then I know that this part could be called 30 minus m. And how many more is up there? Well, it's 30 minus m, that top part, minus m. That's what we did here. 25 minus 5, 30 minus m, minus m. And so if you have 30 and you take away m and you take away m again, what you have is 30 minus 2m. And that's where they're getting the answer, number 3. The wording is, take some thought. Number 4 is just some practice and playing with and trying to figure them out. We're trying to rearrange so that the first 3 of these gives us a sum of 4x plus 3. And then we also want it to be true that the last 3 give a total of 4x plus 4. And so when you work on that, one of the main things is trying to get it to add to be 3 and something else to add to be 4. And notice there are 2 minus 3's in there. And so if you have a negative 3 and a 5 and a 1, let me do my colors the right way here. In the blue set, if I have 2x plus 1 and x minus 3 and x plus 5, when I combine those, I do have 4x, and I have 1 and 5 is 6, and minus 3 is 3. So that is 4x plus 3, and that's what it asked me to have for the first 3. In the last 3, of course, the x plus 5 counts for both groups. X plus 5, x plus 2, 2x minus 3. And if I combine those, that gives me, in this grouping, 4x, and 5 and 2 is 7, minus 3 is 4, so 4x plus 4. So that's just a little bit of, again, kind of the trial error, guess and check, making sure that you have the combinations done. And of course it does not matter, you know, which order you put these two in, and it does not matter which order you put these two in. The x plus 5 is the one that has to be in both sets, and so therefore it is important that it be right there in the middle. The rest of them could go in either order, as long as the blue is in the blue and the green's in the green. Either order would be fine. All right, that's the end of this recording. Thank you.